Now, before we go on to B part 2, let's do a quick recap. Now, whenever you have a log function, right, for that log function to be defined, okay, you need to take note that there are actually three conditions there. Number one, the a must be more than 0. Number two, the base has to be more than 0. And number three is that the base cannot be 1. So if you observe the log functions that we have are log z, okay, we have log y, okay, and of course that log of z plus y. Let's just focus on these two log functions first. For log z to be defined, this means that z, according to what we have here, must be more than 0. Okay, so that's the range of values of z. Z must be larger than 0. Now, then to answer the next part, explain clearly why lies in that range is because we know that y as well must be more than 0. And because of the fact that z must be more than 0, we can rely on what we have found just now. Okay, from here, right, this means that the y square over 1 minus y must be more than 0. We know that this one here is a square function, and square functions are always positive. So if this whole thing is positive, numerator is definitely positive. This tells us that the denominator 1 minus y must also be positive. It wouldn't make sense if this is negative, right? Because positive needs to be positive to be positive. So this tells us that the denominator must be positive. Okay, and once we have this, okay, let's minus 1 on both sides. Okay, and let's divide by negative 1, or let's multiply by negative 1. Doesn't make a difference here. Remember that when you multiply or divide by a negative number, the inequality sign will swap. So let's flip it. Okay, and this will be 1. Okay, so since y must be more than 0, because there's a log y function by itself, right? This has got to be more than 0. And at the same time, y must be less than 1. Okay, we come to the conclusion that y must be more than 0 and at the same time less than 1. And that's how we explain that y lies between 0 to 1.